Addition of whole numbers can be really easy if you understand the why behind it. So we're going to figure that out using this problem, 2,437 plus 1,289. We're going to solve it using the standard algorithm, but I'm going to use this place value chart to explain the why. So what we're going to do is we're going to set up our problem showing the top set of numbers. So in that, I have two thousands. And I'm going to use picture models just because I don't have the space to use all of those base 10 blocks. So I have two thousands, I have 400, I have 30, so 3 tens, and 7 ones. 1, 2, 3, 4, 5, 6, 7. And what I'm going to do is I'm going to add in the second number. Now I'm going to use a different number, a different color to show that process, just so you can see where I'm getting my numbers from. All right, so let's go ahead and solve this problem. All right, so starting with my ones column, I'm starting with 7, but I need to add 9 more ones. So I'm going to add them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I notice I have a whole lot of ones cubes here. I wonder if there's something I can do to trade my ones cubes into a bigger model. Well, let's see how many I have all together. I have 1, 2, 3, 4, 5, 6, 7 that I started with, and then I'm adding in the 9. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can take 10 of those away and trade it in for a tens rod. So I'm going to go ahead and show myself doing that. So I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away, and I'm going to trade it in for a tens rod. I'm going to add a 10 rod in there. So now I want to see how much I have left. I have 1, 2, 3, 4, 5, 6 left. So in my problem, I'm going to show what I did. I have 6 left. I traded 10 of them in, and I created a tens rod, and I added it to my tens column. So I took the 10 away from here, and I added it here, and I show that with regrouping that 1. And I have 6 ones left here that I didn't get rid of. Okay, so now I'm going to go over to my tens column. In my tens column, I had 3 to begin with. And then I regrouped that 110, that 10 that I got from my ones. And now I have to add in 8 more tens. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Again, it looks like I have a whole lot of tens here that I probably can trade in for 100. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I know that 10 tens equal 100. So I'm going to take 10 tens away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to take this group away, and I'm going to trade it in for 100 flat. So now to show my work up here, I have 2 tens left. That's going to be part of my sum. I took 10 of those away, and I added it to the hundreds column. So I'm going to regroup a 1 up here because I added that 1 in. I have 2 tens left, and I regrouped to make another 100. So now let's go to my hundreds column. I started with 4 hundreds, 1, 2, 3, 4. I added another by regrouping to give me 5, and now I have to add 2 more. 1, 2. Now I'm looking at that amount, and to me, I don't think I can add 1,000 because I know that 10 hundreds equal 1,000. So let's see. 1, 2, 3, 4, 5, 6, 7. I only have 7 hundreds, so I can't trade them in. I'm going to go ahead and record my amount here and then put it there. As I work to the left, I'm going to drop that comma and I'm going to come over to my thousands and I'm going to add in that last 1,000 in my problem. And there's my last 1,000. That means I have 1, 2, 3 total being an addition word, to give me 3,726. So for those of you who like the standard algorithm, this is the y behind it. 7 plus 9 is 16, which is what we had over here. But we put our 6 down, which is what we had left after we regrouped 10 of them to make a 10. 1 plus 3 is 4. That's what we had here. And then we added 8 more. 4 plus 8 is 12. I can't put 12 in this column, meaning that I can regroup 10 and make 100, and I have 2 left. 4 plus 1 is 5. That's what I had, my 4 plus 1. And then I added 2 more to give me 7. I don't need to regroup. I need 10 hundreds in order to regroup, and I only had 7. And then I had my 2,000s. I added 1 more to give me 3,000. And that's the standard algorithm and the why behind it.